Hi, we are taking a look at Chapter 8 this week, and it's taking a look at Unix and Linux utilities. Now, right off on the assignments, don't do projects 8, 13, 14, 15, or 19. On the Discovery Exercise 7, log in with your account and then only run ifconfig. So make note that when you run ifconfig, you have to type in from your home directory /sbin/ifconfig. There's one other problem where you're running traceroute. In that case, you have to type in /usr for user /sbin/traceroute. So we'll take a look at that when we get there. Some of these paths aren't set in this Unix or Linux environment, and you just need to specify where the actual program file is to run these applications. And then don't do Discovery Exercises 15 through 22. Okay, so to start right off here, let's squish that down a little. Okay, so we'll take a look at, or actually I should say, Unix, Linux utilities are classified into file processing, system status, networking, communication security, and so on and so forth. We will take a look at some of the networking ones today, as well as system status kinds of commands. So categories, network tasks, programming tasks, and then file processing tasks. And the file processing, of course, as we've done already, makes up the largest category of applications that you might run within Linux. Let's see. Excuse me. First off, taking a look at the dd command. So what we're doing with this is you're copying an input file and converting that file into a different format. So you can, so IF designates the input file, OF the output file, and then at this point conversion, CONV equals, and then you can convert files into, well, for a good example, lowercase or uppercase at the bottom here. So the example that we have is cat zoo2. We'll take a look at cat zoo2 and you can see some of it's uppercase and lowercase. The command is dd to change the case. The input file is zoo2. The output file is zoo2_test. So in this example, zoo2_test. Make sure you note that that output. And then CONV for convert equals lowercase. This is the output you get from the command, and then what zoo2 test actually looks like. So if we run this, if we look at, let's see, cat and zoo2. Okay, so you can see a combination of uppercase, lowercase, and so on and so on. You know, the better example might be to convert everything to uppercase. So you can do that. We look back at this particular command. Lcase is lowercase, Ucase is uppercase. So if we go dd, and then input file if equals, and then we'll use zoo2, output file equals zoo2, and I guess we'll use test, and then CONV for convert equals ucase. So 114 bytes copied, cat zoo2 test. And then the entire file, as we see, is all uppercase. Okay, the next command we'll take a look at is df. So this utility shows hard disk drive usage. So we'll take a look at that. Now -m, make sure that df and then the option being -m displays sizes in megabytes, for instance. So df, this shows it in 1K blocks. That doesn't make a lot of sense to us for the most part. We're typing df-m to change that into megabytes, and so we have our particular file system's temp file system. Now remember, this is probably the most useful or the most specific particular device. So SDA2 with SCSI drive A2 from the first primary drive and in the second partition. And remember from our discussion on the mount command and looking at these devices, it's SD is SCSI drive or SCSI device, A is the first particular device on that chain, and then the third partition. Okay, so this is really, excuse me again, what we're looking at are the devices and the drives and the partitions on those particular drives on this system. So at this point, we're looking at this drive has 15 now, and remember these file sizes are going to be a little odd, and the memory is a little odd because this is a virtual machine running in a virtual environment. So with that said, it's sort of a subset, if you will, of the regular main operating system. So the file system being used on, I think to explain a little further, we especially see that in the memory area. Now, under blocks, this drive has 15,000 meg on it, which is 15 gig. Used is about 3 gig, 3.7 gig, and then available about 11 gig. So it's 27 or 26% used. Now SDA3, this particular partition, and there's also some issues in that with these sizes of drives, of devices. This is a partition, and SDA3 is a partition that actually has 23 gig of space in it. So, you know, between the virtualization and the actual partition sizes, then you have a kind of a combination of sizes and settings. So once again, this is how many blocks, or how many blocks in megabytes, how many megabytes of space this particular drive SDA2 contains, and it's 3.75 or 3.735 gig, or 3700 meg is used, and about 11 gig is available. Okay, so that's what this df command shows us. Now also we have top and uptime. So top monitors the CPU tasks, and the PID is the process ID. Uptime shows how long since reboot. Let's take a look at uptime first. Let's see, spell it right. Okay, so this particular system has been up for 46 days. That's what that tells us. Now there's 4 users, I think, logged on at this point in time. So if I were to just type in who, I would see that there are 3 root processes, and then I'm logged on as well. If any of you were logged on at this point in time, we would see 5 users. Okay, so with that, what else were we looking at? I forget. Top. Okay, top displays the processes, and so this is up here at the top left-hand corner is PID. That's process ID, and this is the process ID of that particular process. MySQL is running out there. Root is running out there, and these change every so many seconds. With any typical mainframe operating system, even your desktop computer, if you take a look at the processes, those are changing, and this is obviously listed by the top ID, the top process ID. The top CPU user will be at the top, and here in the center is CPU, %CPU, and so we can see 2%, 0%, and so on and so on. Now, and how much memory it uses, this particular process uses. Now with this, in taking a look at this, and we've spoken a little bit about virtualization, and virtualization is where you put a separate, using some specific software, you put additional operating systems on one server. So instead of having 5 servers, you have 1 server, for instance, with 5 different operating systems on it. Now to demonstrate how little a processor is used with one single operating system, we can just take the percent CPU is at 2%. Now I could go ahead and add, within this environment, several additional operating systems or virtual environments within this virtual environment, and if each one of those CPUs only ran at 10%, I would still only be running from the primary OS, maybe 40%. Not sure if that makes sense. Take a look at, some of you have had, some of you have been in classes where we've discussed virtualization. Some of you haven't. Go out and Google virtualization, and hopefully that'll make a little bit more sense. This CPU percentage demonstrates how little servers, generally speaking, actually use the CPU. So virtualization is a way to increase efficiencies, to better use the resources that you have available. Now, again, keep in mind this process ID, and I don't remember what that particular question asks for when you're looking at top. Now, to get out of top, you can just press Control-C to get out of that top, showing those top CPU processes. Okay, going on to free. Now, this is showing how much free memory that we actually have available. So in this example, we have 1436, 1.4, about 1.5 gig total memory used. We are using about 1 gig of it, and we have about 364 meg free. Now there's a difference. Well, there's no real difference in there as far as what's used and what's free. Part of what's used, though, as I discussed here, memory used for video and other hardware purposes are often not displayed. That memory for video and those other bits and pieces are put into this used area. So this is actually, in this case, what I have free and available for use. Now under swap, that's virtual memory, not to be confused with virtualized operating system. So virtual memory is actually space on a hard drive that is used as RAM memory. If this number on the free memory goes down to a very low number, maybe even 0, that at that point in time the swap memory, the virtual memory, will then start being used. The problem is, as you can imagine, with virtual memory, it's on a hard drive, and the hard drive will, the access times for the hard drive is much slower than for random access memory or RAM. So when applications start loading very slowly, that might be an indication that you might be out of memory, and that some of these applications are being swapped down to that hard drive in a virtual memory capacity. The other thing that may be an issue is, well, two other things. That your CPU, since we looked at top, you can check top to see if your CPU is actually getting pegged. In that case, you would have slow response. Or that this free number here, once again, may be down to 0. So let's take a look at free. In this case, and I think probably we need to do the -M, because otherwise it shows you in blocks, and that's something we're not used to looking at. A block is a half a K, or 512 meg, or I'm sorry, 512 bytes. So looking at this memory, we have a total of 997 meg, so almost 1 gig of memory. And again, that's in this environment, it was limited to that much memory on this particular machine. 964 of that memory is used, and 32 is free. So, in some of the cases when we're trying to run some of these programs, it seems like it may be running a little slow. We're simply getting a little short on memory, and not that it's a big deal for our purpose, because we don't really use a lot of memory. But if there's a lot of us logged in doing some little things here and there, it sucks up a little memory, and it's not a big deal at all. Now here's the swap memory. So it has about 1.5 gigs, not quite, of swap memory, and most of that is free. And typically in machine running well, that's what we'll see. If this number of free memory on the drive were actually to 0, we might see this number of used swap memory increase and the free amount decrease. Okay, so hopefully that makes sense on that. The next piece is taking a look at running these processes. Now in this case, man, of course, is looking at the manual, and df is looking at the df command specifically within the manual, which is terrible and cryptic, and we would never do it anyway. But this ampersand sign will tell Linux to run this particular process in the background. So we can go out to a command prompt and actually do other things and let this run in the background. Now, one of the real-life applications that you may use with this ampersand and running an application or a process in the background is if you are setting up, I don't know, 10,000 users per, for instance, on the server. You don't want your machine to be all tied up for, I don't know, a matter of an hour while all these users are being installed and their accounts being set up and updated. So you can go ahead and run that particular task, that script creating those accounts in the background. You can still go out to the command prompt and do other things in the meantime. So let's take a look at this. Man df ampersand. Man df ampersand. And again, that ampersand runs things in the background. Okay, so I'm just going to exit out of this. Now you can see that it says process stopped, man df. Now if I take a look, if you can see that ps shows the processes. So we should see in these processes, bash is our shell, ps is the command that we actually use to see the processes, and man is the other process out here within this. So if we wanted to, and notice the process ID on that. So in order to kill it, we can just type in kill space %man, and that should actually go ahead and terminate that particular process. Let's try that. Kill %man, because that's the name of the process. Okay, it says, the output says stopped man df, and if we look at the processes again, we'll see that man is no longer in that list of active processes. Let's see, next we'll see there are quite a few small commands that I really haven't worried about. CMP compares files, ispell, graph, dump, restore. Mail, I think we will completely ignore that because we don't have the mail system set up to do that. DU is disk usage. Now let's just take a quick look at that here. So DU-H. Well, first of all, let's run DU first. So it really doesn't tell me a whole lot. These are my particular. This is my particular home directory, and I have a folder called bin, spreadsheets, public, HTML, Mozilla, and fonts, and then we have 12, 8, 8, 8, 4, and 4, and whatever for 260 total. That doesn't tell me quite as much. Maybe it's just not as descriptive, I should probably say. If you use a -S or -H option, this tells me just a little bit more in that there's 12K of files, for instance, in this bin folder, 8K in spreadsheets, 8K in public HTML, and then a 260K total for all of the files I have in all the files and directories I have in my particular home directory. That's home/SE Scott. So that just gives me a little bit of information about how much space physical disk space I'm using. So we'll go back to here. Let's see. At this point, we'll start taking a look at some of those network utilities. So, and again, notice this. Notice the sbin/sbin/ifconfig. That sbin folder is where that particular program is. And if we and the path isn't. We could set the path to where we wouldn't have to type in sbin, but at this point in time, it's not set. So if I type in /sbin, designating the folder, and then ifconfig, we can hit enter. Now, excuse me, ifconfig is showing us the IP configurations, the Internet Protocol configurations on this particular computer, on this server. Now, on DOS machines, not DOS machines, but PC-based machines and Windows-based machines, it's ipconfig. So keep that in mind. On Linux, it's ifconfig. On Windows machines, it's ipconfig. So it shows you a whole lot of stuff. Ethernet 0 is our first Ethernet card. If we had additional Ethernet cards or network interface cards within this box, we would see more Ethernet 0 and 1 and 2 and 3. It starts at Ethernet 0 because that's the first one. Now we talk about a hardware address, which is the MAC address or the physical address of the particular card, and you talk about that and have talked about that in different classes. This is the particular hardware address for this particular card. Now this next line is probably the most important piece of this. So the internet address of this particular computer is 10.48.7.2. We know that that's a private address, and that's an address set up internally for this server. All the other computers in our labs are 10.48.7. something, you know, and I think that range goes up to 7. I have to think about it. It actually goes. Some of those are 10.4, 10.48.4. something. Third at 10.48.5, 10.48.6, and the labs are 10.48.7. Now, most of you have probably been through your Cisco courses and understand what that means. So this is simply to show us what the IP address of this particular machine. Now, the broadcast, as many of you know, or some of you know, is the last IP address on a particular network. The network address is the first. The broadcast bcast address is the last. Now, that really doesn't matter to us in this class, and it does as a network administrator, but not that much. Okay, but your network mask, the mask itself, so subnet mask or subnet is all the same thing as mask. So the mask in this case is 255.255.252.0, and this mask applies to this internet address so that the routers and switches and PCs can figure out which part of this is a network and which part of it is a host. So this is mask, and that equals your subnet mask. That probably there's a lot of other stuff about collisions and so on and so forth here, but that probably is really the most important piece of what we see with this ifconfig command. So again, it's just showing us the internet configuration, the IP address assigned to this box, and the subnet mask associated with that. And once again, that subnet mask, between the IP address and the subnet mask, I should probably restate that. The subnet mask makes a determination from the IP address which part is a network and which part is a host address. It's just network stuff. So I think that probably explains that as well as you need at this point in time. It says ifconfig. The next piece is pinging. Okay, so, and remember, Control-C stops the pinging. So a ping just simply goes out and asks, are you there? So it just throws a layer 3 or level 3 request out, an IP request out that says, are you there? Now, in this case, let's go ahead and ping our own IP address, our own computer, right here, and we should see that it replies. So we're going to ping 10.48.7.2. So if it replies, and I'm going to hit Control-C to stop that, if it replies, it means that this particular network card on this particular machine is working up to a certain point, and that point means TCP/IP or internet connectivity. Okay, so that's good. Now let's go out to, you can ping an IP address or Yahoo. Let's try yahoo.com, and this may take a second to load ping and to go out and see if Yahoo is there. Now with some of these IP addresses, like Yahoo, there's some DNS resolution sorts of issues, and let's go ahead and stop that right there. So it looks like when I say DNS resolution issues, that it might not ping back yahoo.com, but it might ping back an IP address. Some of that is done for security purposes. Some years ago, there was a major denial of service attack that hit Cisco, I think Microsoft, Yahoo, a number of major companies that basically was, you know, in a nutshell, pinging those devices so frequently that they could only respond, those devices, Yahoo, Cisco, so on, could only respond to the pings. They didn't have enough processing power to actually complete any other requests. So that's pretty amazing, and basically this ping is kind of an example of that. Now, what we see here from our results, so we pinged yahoo.com, and what we see under the results, or the stats, is 6 packets transmitted. That we see that. 6 received by Yahoo, 0% packet loss. So that means that we have connectivity from this point, the server, to Yahoo, and that's what this command of ping is telling us. Now the next piece, remember, Control-C stops that. I think the last one that we're looking at is traceroute. So you can tell, you know, where the message is hitting routers, you know, the particular devices that are being hit between here and there being wherever you're going. In this case, we're going to look at www.umt.edu. So that's UM-Missoula's main web page. So we're going to trace route. Now notice this, /user/sbin, and user spelled USR, /sbin/traceroute. That's where the traceroute program is located. And we're going to put in our web address in here, our URL. So user/sbin/traceroute. Where are we going? www.umt.edu. So it'll probably take a second to come back here and look at this, or to find this route. I ran it a little while ago, and it did take a little time. So it's saying trace route to www.umt.edu. The first hop is 1048.7.252. The next hop, 1055.254.33, and these are particular routers, or probably primarily routers out there on this network. 172.17.41.61, 172.17.33.76, finally 172.17.33.42. There might be one more hop, and then it finally hits, and that is www.umt.edu. Is actually that's an alias. www.umt.edu is an alias for mum.www.gs.umt.edu. So it's easier to type in umt.edu than it is the rest of that stuff. This tells us how many hops, or how many computers, routers specifically, there are between our server and UM-Missoula's web server, and how quickly each one of those hops responded. Now that's pretty amazing, because when you go out to Yahoo or other places, Gmail, Google, there are a lot more hops in between. So this demonstrates that this internet connectivity is really a very complicated sort of issue, and there are a lot of devices between here and there, especially if there is a long ways away. UM-Missoula, the website out there, is very close. So even at that, there's at least 4 hops in between our server and the web server out there. Now I think that is the last point of discussion. Also within this PowerPoint is command summaries, file processing utilities, additional file processing utilities, system status utilities, network utilities. Most all the time what you'll use is ifconfig and ping. That's probably what you'll use most of the time. Under communications utilities, there's mail, which I don't think we'll use at all. That's just not set up. Security, we use change mode all the time. Let's see, programming utilities. We'll start using, I think, GCC or G++. I think GCC is what we'll start using in the future. And then I can't recall any source code management utilities that we'll use. But yet, it's a command. I just wanted to have that command summary out there for you. And then these are just different kinds of utilities. Cal, we've used that to display the calendar, CD changes directories, and so on and so on. So with that, I think we have discussed Chapter 8 with these Linux utilities. And once again, don't do projects 8, 13, 14, 15, and 19. On Discovery 7, Discovery Exercise 7, when you run ifconfig, make sure that you use that /sbin/ifconfig. And remember, for traceroute, it's /usr/sbin/traceroute. And again, that's just where the program is maintained. We don't have a path set up for it. We could change that. We could make that work, but we can just use it as is, which is perfectly fine. And then do not do Discovery Exercise 15 through 20. So I think that concludes Chapter 8. Thank you.